Hi guys, Arthur here from Homeowner DIY. In today's video, I am going to replace a gas 40-gallon water heater. Now, I already do have a water heater on the channel. It was an electric. The procedure is very similar, but the gas consideration changes a couple things. Because it's gas, you need to have 18 inches of copper here locally where I am. And you also need to address gas and your exhaust. Guys, because this is a gas water heater, legally speaking, you need to have a gas license, which I do have. You can go to the big box store. You can buy everything that you need. I mean, you can install this on your own, but like I said, legally speaking, you need to have a gas license. What I will do is I will link in the description the electric water heater I did, so you guys can easily navigate and look at that water heater as well. I'm going to try to do my best to get this as close to local modern code as I can, but the homeowner wanted a cheaper install, so there will be a couple things missing, but I'll do my best to get this as close as I can to modern code. So with that in mind, what we'll do now is material and tools. Alright guys, this is our materials list. So the first thing we have is our water heater. This is a Rheem. It's a 40-gallon. This is the cheapest water heater that they have. It's only a 6-year warranty, but that is what the customer wanted, so that is what I'm going to go with. Alright, this is the rest of our material. So I've got 3-inch deck screws. I've got wood in case I need to space the tank off the wall. I have my earthquake straps, flux, solder, gas tape, which is yellow, regular Teflon tape, pipe dope, or also known as pipe compound. I've got a couple 4-inch C-vent 90s, and then I have some 4-inch C-vent duct. I don't know how the dimensions are going to change, so I'm just going to be prepared. I've got a 1/2-inch copper, a flexible gas line, a sweat by sweat ball valve. For copper fittings, I have T's, a 1/2-inch FIP by sweat. That'll be for a vacuum breaker, which is here. I've got other fittings. I already have my 3/4 FIP by sweat adapters. So it's 3/4 by 1/2 copper. I already prefabbed these on just to save myself time on site. I have 1/2-inch black steel nipples. And then I also have my PEX tray, which will have clips and then also shark bite cap if I need it. Guys, this is what I believe I need for material for this job. So what we'll do now is the tools list. All right, this is our tools list. So starting in the back, I have my torch. I have a spray bottle. The spray bottle will be soapy water to double up for testing for gas leaks once that's all done. I have my finishing kit. So I have crescent wrench, channel locks, copper cutters, mirror, anything else I might need. I have a crinkler for the 4-inch duct in case I need to change anything for safety equipment. Earplugs, safety glasses. I have a skill saw in the back. Hand tools, hammer, knife, measuring tape. For my cordless kit here, I also have the cordless grinder. For pipe wrenches, I have a 10-inch, 14, and a 24. The red is a hand truck. I've got my socket set, and then I have a garden hose to drain out the tank. This is what I believe I need for tools for this job, so let's get started. First thing to do is to start draining out the tank. So this is the drain for the tank. I already hooked up a hose and I put it outside. This is the gas shutoff. This is our water shutoff for the cold. Our TMP, when you flip the lever out, that'll open it, introducing air into the system to help drain out the tank. This is the union for the gas. We're gonna have to loosen that off, and then this is our exhaust for our tank that goes to the chimney. Here I'm spraying the C-vent with water just to make sure that it's cool. A C-vent is a single-walled vent, so it will be hot to the touch. A B-vent is a double-walled vent, so it will not be hot to the touch. So the first thing, make sure that the tank is draining out because it'll take a while. I'm loosening off the screws for the exhaust. These are 1/4 inch screws, so I have a 1/4 inch socket to loosen these off. With the screws removed, the exhaust can be removed. So the exhaust is only held into the chimney just by a friction fit. There's no screws or anything holding the two together. Next, we're going to disconnect the gas. So the nut that I'm loosening off, this is a union. This is the way threaded pipe goes together. So crack the union loose. And this is just it's a friction type of fit. It's just a seat, and then the nut will hold the two parts together. Once the union is loose, it's not uncommon to smell a little bit of gas. Don't be alarmed by this because this is normal, especially when the valve, like in this case, is a fair bit older. Here I'm removing the vacuum breaker. Because the piping is still all soldered together, it's easier to remove it now, but also by removing it now, it'll allow more air to enter the system and help drain the tank out that much quicker. Here, the pipe above the valve is still full of water. Below the valve, it is empty because the valve is shut off. The bottom pipe can be cut, but if you cut above the valve, you're going to get soaking wet. And then the hot is all drained out, so there's nothing on the hot side. Here I'm removing the 90 and the union that is attached to the gas line. I'm removing this because I can't get the tank out from between the gas line and the rack to the right side of the tank. I'm cutting the swept-by threaded adapters that connect to the tank. So I'm basically cutting this as close to the tank as I can because I don't know how I'm going to repipe this. So for this seismic, I'm going to use this stud here, and looking in the little hole you can see the edge of the stud here. One thing that you have to keep in mind is we have this laundry duct, that is the white pipe, and then down below we also have ABS. So I'm going to have to space the tank off the wall to allow these two pipes to go in behind the tank without issue. So for measuring off the tank, the top strap will be at 42 inches, and then I eventually decide for the bottom strap to be at 18 inches. So using a couple 3-inch deck screws, I'm going to screw this block into the studs. I'm going to put 4 deck screws in total. These are number 8 3-inch deck screws. Once the block is mounted, make sure to give it a shake to confirm that it's nice and solid. The second block I'm going to mount like this, perpendicular. The reason is because of the white tube, and then there's an ABS pipe down at the bottom. So start your screws like this to make it easier, and then hold the block tight to the other block, and then tighten the screws in. For the seismic, it's a 3/8 sockets for the screw. Make sure that there's no wires or anything going through the studs where you're going to put the screw in. If you tag something, now you have a big ugly fix on your hand. So take an extra couple moments just to make sure that you don't see anything that you may potentially hit. So for the bottom strap, I decided to move this to 18 inches to be just above the gas valve. I put the screw into the block on the left, but I didn't realize at the time that it's not actually a stud. So I take it out and then I move it to the right. Now all the straps are in, so you can see the block that the tank will be strapped to, and then all the other obstacles in the way that have been contended with. The new tank is higher than the old one, so the copper will have to be cut a little bit higher up before it can slide the new tank into position. Here I'm cutting back the copper so I can get the new tank in. Guys, keep in mind, this pipe is all old, so you don't want to disturb it any more than you need to, and that's when the grinder is a good tool to have. A Sawzall creates so much vibration that you can potentially break something, and then you have to go and fix it. Now I'm going to attach the top seismic strap. So I measured this off to go under the T&P, that's the brass piece to the right. So here I'm tightening up the nut with a ratchet wrench. If the tank is too loose, either this nut needs to be tightened up more or the bracket needs to be moved down the line. You see how the holes are in the straps. With both straps on, you can see that placement does matter. So you can read the literature on the side of the tank, give it a shake, and now it is time to connect our copper. I would say do this as soon as the tank is strapped in, so you have time to fill it when you start doing the gas portion. So here I cut the copper to give myself space to put Teflon tape on the dielectric nipple. Now, because this is white tape, you need minimum 6 wraps. I decided to go with 8. To tighten the adapter onto the nipple, I'm going to use a crescent wrench so it doesn't scratch the copper, so it'll look better. So here I'm going to connect the hot together. This is the laundry here, but what I decided to do was to offset 245s for the hot towards the front of the tank to give a place for the exhaust coming off the top of the tank to go to the chimney to the left. So I offset the laundry on a 45 to raise the T because this tank is higher than the previous. You can see the 245s offset that I did to give the exhaust a place to go to towards the chimney. This is our main shut off for the house, so I'm just going to close it, and then I can now cut into the cold side for the tank. After shutting off the water main, be sure to open a faucet upstairs and maybe a hose bib that goes outside, so you will drain the water out and bring air into the system. The last thing you want is dripping water that I have right now from the cold side when you're soldering. One thing about using a grinder to cut copper pipe, you're going to need to take a file to clean up the edge, and you're still going to have to ream the copper pipe just like if you're using tube cutters. Now I'm going to solder one end of the valve. Make sure that the valve is open when you solder so you don't possibly melt the seat. One other thing is, orientate the handle for the valve where it's not going to get hit by anything. The exhaust for the tank is going to be on the left side, so the valve turning to the right won't be an issue. Wipe down all the solder joints with a wet rag or wet paper towel to get the flux off, and then check with a light and mirror to make sure everything is good before you fill the system back up. Turning the water back on, just crack open the main and then let the house slowly fill up. Once the PRV is silent, go ahead and open the valve the rest of the way. Since this is a glow valve, turn the valve back in a quarter turn so the valve doesn't seize to its body. I'm going to crack open the ball valve to slowly fill up the hot side, and I'm going to open the T&P to allow air into the tank. That's what I'm doing now. Now it's time to address the exhaust. So this is the hood. The bottom is 4-inch and the top is 3-inch. We're going to use the 4-inch portion. So the hood will only go onto the tank one way because the brackets are different dimensions. So you can't put this thing in backwards. I'm going to mock up the original exhaust. Since this tank is a little bit higher, this is easy. All I have to do is cut down the pipe. So I'm just going to eye this out and then mark with a pencil and then cut with the grinder. I'm going to reuse the self-tapping screw. So I'm going to put one for the hood into the tank to hold that in place, and then put 2 screws between the hood and the exhaust pipe. To hook up the gas, I'm going to use a couple 3.5-inch steel nipples, and then between the vertical gas line and the gas valve there will be the 2-foot flexible gas line. So for the gas, I'm only going to use pipe compound. I'm not going to use any yellow gas tape for this. And for the flexible gas line, the flexible gas line will make it easier when the tank needs to be replaced next time. Instead of being hard pipe like it was before, using a union. For the yellow fittings for the gas line, I'm just going to use a crescent wrench so it doesn't scratch. Once the gas line is connected, I'm going to turn the valve on. This is a quarter turn valve, so the gas is on. And I'm taking soapy water and I'm going to spray my connections. If you see bubbles, that means you have a leak. But the pressure with the gas system is very low. To turn on the tank, the instructions are on the side. That's what I'm pointing to, the lighting instructions. So this window will show you the pilot light. It's dark right now, so there is no pilot. For this tank, you need to push the knob in. It needs to be on the pilot setting at the bottom, and then keep hitting the igniter until the status light starts blinking, which it is now. With the pilot lid, I'm turning up the burner to the A setting, and you'll see the burner kick on. The burner is now on, so I'll wait until the water heats up to proper temperature. Also, don't forget to put the cover back on, which I'm doing now. So this is our finished tank. I forgot about the vacuum breaker, but I do talk about that at the end of the video. This is our TMP. When you open it, if you have water coming out, that means the tank is now full. If you look closely, you can notice the gas valve is crooked, but that's how it came out of the box. Alright guys, I didn't film this. I made a mistake with the vacuum breaker, but I'll tell you what I did to fix it. So we have the valve there. In the case of the water heater that I just did, this comes off. The valve is here. So what I did was on the vertical, between the valve and the tank, I cut the T in, I 90'd up, and then I put the vacuum breaker there, and that's good enough. Guys, this is what happens when you work so many hours. You start making mistakes and forgetting things. But with that in mind, what we'll do now is an overview of this job. Alright guys, so that concludes this project. So this went relatively well. The only hiccup I had was I forgot about the vacuum breaker, but when you work 14 hours, these things tend to happen. The vacuum breaker needs to be between the valve and the tank. I didn't film installing it because it was already so late. But guys, make sure that your vacuum breaker is between your shutoff valve for the tank and then the tank itself. The time on the job. The time was about 6 hours. I've noticed from my own personal experience, 40 to 50 gallon water heaters take me roughly about 6 hours. And I would say a good portion of that time is draining the tank and then refilling and then making sure everything is working before you leave. But other than that, everything else here went really well. I didn't run into any major issues. I had good access to the tank. There wasn't anything in the way. There were no stairs or anything like that. So I'm happy with the way this went. The cost of this job. The water heater, the seismic, new valve, copper, and then all the other odds and ends. The cost was about $1,100. Guys, this is the cheapest tank on the shelf, and in the last few years, like with everything else, it's just gotten astronomically expensive. For final thoughts, a water heater is not a difficult job, but as you can see with the amount of tools that you need, this isn't exactly DIY friendly. But if you want to go ahead and give it a try, this being a gas, I mean, technically you're supposed to have a gas license, but you can go to the store and buy a gas water heater without a license. So your local regulations and laws will differ, but that'll be entirely up to you. Guys, I hope you enjoyed the video. I hope you learned something. I hope something here is going to help you on your project when you need to go ahead and do that. And guys, until next time, please hit the like button, subscribe, and I'll see you on the next project.